questions about the velocity graph below, so let's be careful. We want to know the acceleration of the object from 5 to 8 seconds, so that means we need to get the slope. Once again, here I'm going to be really careful in labeling my graph. So this point is 8, 0, meaning at 8 seconds the velocity is 0 meters per second. And here at 5 seconds our velocity is 2 meters per second. So we're going to get the acceleration as the rise over the run, or the slope, which is going to be 0 minus 2 over 8 minus 5, which is going to be negative 2/3, or if you want to round that, that's going to be negative 0.67 meters per second squared. All right, is the object moving from 0 to 5 seconds? The answer is yes, at a constant velocity. Now, what is the displacement of the object from 0 to 8 seconds? That is going to be the area under this graph. So let's go ahead and calculate that now. So I have this graph here, and I note that the area is, I will actually take 5 times 2. So the area here is 10. And then for this part here, I notice that the base is 3 and the height is 2. So I get this area as 1/2 times base times height. So that's going to be 3. So my total area is going to be 10 plus 3, which is going to be 13 meters. And I'll say see work above. All right, the answer to question D, does the object ever come to rest? Yes, it does at 8 seconds. At 8 seconds when V equals 0. Now, do we ever see the object change direction? Well, for it to change direction, all of this is moving forwards. All of this means the object is moving forwards. You'd need something to be happening down here for it to switch to going backwards. So the answer is no. It only moves forwards. Lastly, is it possible to determine the initial value of the object from this graph? No. It is a velocity graph, so you cannot. So that cannot be done. All right, so that is question number 3.